Good afternoon, everyone. In the first module, we have seen various standards which has to be followed, introductory parts of the steel design of steel chimneys, as well as various loads which come into contact with our chimneys. So these are the standards which you need to refer while designing the chimneys. So moving ahead, if you look at the design parameters, we have different designs of chimneys. We have different types of big chimneys, but our main focus for today will be the design of a single flue steel liner, which is a steel stack as well. So we can refer any of the design codes, but I'll be specifically following the design with regards to the Indian code. This is a typical design example. You just jot it down. It says the design for a self-supporting steel stack. It means we are going for the first type of steel chimney, which we discussed in our slides. That is which acts as a cantilever action, which has a height of 72 meters above the foundation. The diameter of the cylindrical part of the chimney is 3 meter. The foundation has to rest on medium soil having bearing capacity of 200 kilonewton per meter square. So this is our SBC for our foundation, which has to be rested on. The thickness of the fire brickwork lining is 100 mm, and the lining is supported by the stack throughout the height. The chimney has one breech opening. The topography at the site is almost flat, and the location is of terrain category 2. These all factors has to be taken into consideration when we are designing the steel chimneys. The first one is the basic dimensions of chimney, which has given the total height of the stack is given as 72 meters, which we are considered as 72 meter. Height of the flare is one third of the height of the chimney. So it is 24 meters. The diameter of the flare is 1.6 times of the cylindrical part of the chimney is 3 meters. So it has given. So 1.6 times of 3 is comes out to be as 4.8 meter here. Now, basically, as we know that chimneys are the high-rise industrial structures, so we need to take the account of wind pressure as well. We have computed the wind design speed as shown in this particular diagram, and with the formula as Vz equals to Vb, K1, K2, and K3, where Vb is our basic wind speed, which is 47 meter per second, which is for Delhi. Probability factor as 1 for general buildings, K3 which is the topographic factor for flat topography, and K2 is terrain height structure. So this is our basic, if you look at here, this is our diagram which we need to design and consider. For 72 meters we have calculated as our K1, K2 and this category as 2, and here if you look at, we are getting 47 K2. Okay, now we have to divide all these structures in particular sections so that we can design individual section and then lift it up for the same. Okay, so first I'll explain the first section, and then similarly you have to design for the second sections as well. First, if you look at section 1 is here. The height of the top in section 1 is h equals to 272 meters, which is the toppest or the highest portion of, for our steel chimney at the Delhi side. K2 we have calculated in the same formula. P1 we have calculated as a 1.3254 K square, and we have got around 1.694, and P1 the pressure as we have calculated. Similarly, you can design it for the section 2, where our height reduces to 72 minus 8 meters, because we have divided each sections in terms of 8 meters a section as. So section 3 will work it out here, section 4 is worked out here, and section 5. Okay, so we have to divide all our sections in a typical height of 8 meters, and then we are considering for the same. Okay, and that height calculated, the h value has to be calculated from the ground level. Similarly, now for determining the moment, similarly we have calculated for section 6, section 7, section 8, and section 9. So next, the most important thing is to calculate the moment, and here as this will be resting on the soil base, and due to wind forces as well, wind force has a major impact on the overturning forces. So we'll calculate the moments as the basis, and these are typical 9 moments which are calculated at the base of each and every point in terms of kilonewton per meter. P1 H1, P2 H2. Similarly, Now the most important thing is, if you look at here at x1 and x2, we at x1 and x2 here, if you look at here, we are having moments at different sections as well. X1, X1 will take it as X2, X2, and at each sections also will have a moment. Why? Because from that section we'll be lifting our chimney, so it will be also a critical point for a design part. Now, so similarly, we have calculated section moments at x1, xy, x3, x2, x6, x7, and x8. Till x8 we have calculated here. Now the next is to design a chimney shell. We'll calculate the stresses of the various things that is due to the self weight of the chimney, due to weight of the lining, and as well as the stress weight of the vent. So here Fx is given as it is given in terms of H. It's a formula which you need to take into consideration. From that, we have calculated various stress which will be acting, and from that, we have the maximum values. For the design of section one, we have to design individual sections individually. Similarly, we have gone for, we know moments at the section, we know the stresses at the section. From that, we can calculate the effective thickness of the section. Then from the D by T ratio, we'll get from the HE by D ratio. Similarly, we'll have permissible tensile stress here. Then we'll be going for the riveted joints, which will be in tension, but obviously, similarly, these we have calculated various stress measures, then maximum stressors, and hence we got it as our safe. Similarly, all the stress calculations and moment calculations we have to do for the individual sections. And at the end, we need to design the anchor bolts for the uplift force. Okay, so for that we are going for this formula, which has been come from the IS 16533 part 2 1989. This formula, from that we have calculated number of bolts here, spacing of bolts, and we have provided M30 bolts. And the last and the most important thing in this section is the design of foundation block. So let us provide, we are assuming that let us provide solid foundation in the form of frustum of a cone. Why we are providing the form of frustum of a cone is, when we are providing the frustum of cone, it will have higher resistance and higher resistance towards the overturning forces. So we are going for the frustum of cone. For pedestal, we are using this formula, pi h by 12 d1 square d2 square. We have assumed an angle of as a slope of 45 degree over here. For this also, we have calculated volume of the earth fill, total wind force acting, wind moment at the base, because it's an important section. This is the eccentricity, submission of all the weights which will be acting, at the end we'll have gone for the maximum base pressure. And as we know that we'll have to add some factor of safety against overturning as well, we have gone for the overturning moment here, the restoring moment, and we have got a factor of safety as 3.49, which has to be greater than 1.5 as per our design codes, and hence it is safe. Now we have to consider, like, if you're going for check against sliding also, we have to assume a friction force, or the coefficient of friction, as mu equals to 0.35, and then we have calculated the friction force, which comes out to be safe over here. So this is typical salient features of chimney from the Kogan plant, Gandhar, and as you can see, it has number of flues as 3, height is 100 meters, type of flue is steel. So it's a kind of steel design chimney which you can go through it once. And this is all for our design of chimneys. For more details and for this structural design of the steel structures, you can refer Subramaniam or Ramamurtham textbooks. And thanks a lot. Thank you.